All right, so this is understanding the limit in algebraic approach, and these are the practice problems at the back of the book. Or back of the packet. So we'll just start from this page. First up, we got limit questions for piecewise functions. So here we go. A, we were asked to find the limit limit of g of x as x approaches -2 from the left. So this is a one-sided limit, one-sided, and this means -2 from the left. Alright, so I look at -2 in my domain, and it looks like there's two spots where -2 can be, but when we're talking about -2 minus, what we're saying is a number very close to -2, but on a little bit more negative of -2. So how I think about it is I think of this value as something like -2.001. If you imagine a number line here, here's 2, there's -2.001, and this on the other side would be -1.999, something like that, right? So a little bit on the left side would be around that value. So I think, okay, -2.001, which one, where does that fall in the domain? And we can see that -2.001 is right here in this domain. So what I'm going to do is I'm going to plug in my value of -2 and direct substitute it right into this part of the piecewise function. So what I need to do is I'm going to plug this into 2x squared, but I'm going to replace it with -2 plus 3, oops, not x, but -2. And what I'll end up getting is 2 times 4 minus 6, and that ends up being 8 minus 6, which equals 2. So there we go. That's 2. Now I'm going to do this next one, b, -2 plus. So again, this is kind of like something along the lines of like -1.999, which is a little bit right of -2. And that number, 1.999, falls in this domain. So what I'm going to do is I'm going to plug -2 into the bottom part of the piecewise function, which ends up getting 1 plus 1, and this also equals 2. This sets us up nicely because in the next question, it asks us for just the limit of g of x as x approaches -2. So notice that in the previous two parts, they were both one-sided limits. Now, if there's no plus or minus on the exponent, it means this is a double-sided limit. What that means is we need to check both the -2 minus and the -2 plus to see if the limits actually converge into one spot. So here we go. I'm going to write the limit as x approaches -2 minus of g of x, and I found that from part A to be 2. I also found that from part B, part A. Now I'm going to check limit as x approaches -2 from the right, and found that to be 2 as well. Maybe I'll use a different color. I found from part A that this was 2, and then from part B that this was 2. Now I notice that they are both equal, and that's great because the proof to say that a double-sided limit exists is that the left and right side have to be the same. And so I know the answer is 2, and the reason is because the limit as x approaches -2 minus of g of x is equal to the limit as x approaches -2 plus of g of x. So that's the reason.